Fine. So this is going to have to be quicker than even than I thought it was. Okay, so I'm talking, as you see, about using particularly pgzero and the Raspberry Pi, but it's a little bit more about, really about my experience in teaching the boys in a general boys club in West London, where I live and work, about coding and so on. Just intro shot here. I have slides because people expect slides, but as usual for mine, they're basically the headings I'm working against. You won't see much. You don't need to look up there, really. Okay, so kind of summary, so after which you can leave if you've kind of heard everything I'm about to say anyway. So we're talking about boys in years 8 to 11 at school, so that's more or less 13 to 15-year-olds. They're not intrinsically interested in coding. The club I run is a general-purpose club. We do sort of geocaching, football, and make models and have quizzes and so on. So they're interested enough to come along and do whatever it is I'm doing, but they're not it's not a coding club as such. We're using, for this, Raspberry Pi with pgzero for software and the CamJam EduKit, the first one for some hardware work, and I'll talk a little bit about why in a moment. So I was running 4 workshop sessions of 90 minutes each, pretty much, on each of 4 successive Saturdays. The club runs on Saturday afternoons, so I was just making use of the club schedule as normally. So this is not, in some way, a 100% success story. It doesn't, end with swelling strings and the kids, winning a competition at MIT or anything like that. It's just a sort of a regular, it's not a failure either, just a regular slice of life. This is what I did, this worked, this didn't kind of story. So a little bit of background to the project. I've been involved with youth work for about 25 years now in South and West London. As I said, there's general purpose clubs, so there's, we're looking at a general coding session that didn't expect them to know too much. In fact, knowing the lads, I expected them not to know too much. So the plan was to have, of the 4 one-week sessions, to have 2 sessions on software using pgzero and 2 sessions on hardware using the EduKit. And my idea was that by the end of the 4th session, I'd be able to link those 2 together so that in some way you could, I don't know, have when the ball hits a sort of a block, something would light up, or some kind of way of connecting the 2 together. As we'll see, that didn't quite work out. Okay, but why? The whys of things. Why use a Raspberry Pi? This is kind of an easy question to answer. Well, number one, it's cheap. So a few years ago, so for those who don't know me, I've been involved with Python for, 15 years or so. I do various things to help out in the Python Software Foundation. I'm actually list owner for the Python list. I answer questions on the webmaster address. I do various other things around Python. If you sort of look through mailing lists, you'll find my name scattered around there. And a few years ago, the Python Software Foundation, in one of its, I think, quarterly actions, was kind enough to award me the sort of Community Outreach Award, or whatever it's called. And with it, which is just a little recognition, it's very nice, and with it comes a little purse of money, nothing great, but it went into my PayPal account, which I created for the purpose, and sat there ever since. And so when this idea came up, I thought, well, let's use it for this. So somebody tweeted that RS was selling off Model B Plus Raspberry Pis at a nice cheap price, about half price. So I went and bought a few of those. I went to Pi Hut to get a few of the accessories. And, for a reasonably low budget, we managed to get 3, we already had 3 sets of working Raspberry Pis, the CamJam kits for £5 each, and we already had some screens, fortunately, from somewhere else, which is an expensive item if you don't have them already. We also got the VGA HDMI adapters. Okay, so they were cheap. Another thing, of course, the Raspberry Pi in general, it's different from the black box computer the kids always use. I mean, to some extent, I've spent the last 2 days, the first time I've actually been to the conference at all. I spent the last 2 days over in the education track and simulation centre where everybody is using Raspberry Pis all the time. But perhaps not everybody has seen them or knows them or is familiar with them. The thing with them, one of their ideas, is that it's not the sealed black box laptop or game console that you have. It's a very raw device. It's somehow inviting. That's the idea. It has a sort of educational aim, and so I was hoping that it would have that effect on the kids. Also, I wanted to, part of the workshops, I wanted to do sort of electronics, little LEDs and buzzers, and it's much easier to do that with a Raspberry Pi than putting something in the back of a PC or a laptop or so on. And it's a Raspberry Pi, so parents have heard about them, kids have heard about it. It's quite an easy sell. You're sort of selling something which is a bit of a buzz already. There are equivalent boards that people can use that do equivalent things, but it's a Raspberry Pi, and everyone's talking about them. Okay, so that was why Raspberry Pi. Why pgzero? I don't know if you've come across pgzero yet. I can't see if Daniel Pope's in the audience here, but there are people around who may have met Daniel, and he's put together a lightweight framework around Pygame. Pygame has a little bit of a startup cost in the sense of there's a little bit of boilerplate you have to go through. If you're trying to teach this in schools or to clubs and so on, you have to get through a certain amount of code just to get anything working at all. So a few months ago, Daniel put together, who's a great game designer, by the way, put together this PyGameZero framework, which lets you get going much faster. He demoed it at a London Python dojo, which I was at. I ran up a game with the team I was in, a breakout clone. I took that next day to the Twickenham Code Meetup, which Kat Lamin organises, which I'm going at, and was able to show it there. And all the teachers said it needs to be simpler, it needs to be simpler. But ultimately, it was a quick way of getting something going in a Pygame-like environment. And the advantage of PyGameZero, it builds on Pygame, so you can then, when you sort of run out of its simplicity, you can drop back to full Pygame, as it were. Okay, so that was why Pygame. Why the CamJam Educator? I don't know if you've seen this. I meant to have a photo and I didn't have one. It's basically a little tin of electronics. It costs £5 and gets you going to a breakout board, a few LEDs, a buzzer, and so on. And it's just very, it does what it says on the tin, literally, because it is, in fact, a tin. It's quite cheap, and they produce worksheets as well. So if you're interested, if you're doing this kind of thing, it's very well worth it. It's not something you couldn't buy yourself. You could buy LEDs, you could buy resistors, but it has it all there, and you know it's going to work. Okay, what was my approach on the day? So for the breakout clone, we had, I'd already sort of, as I say, picked up the code we'd done at the dojo, and then I worked out a 12-step version of it. So my approach was essentially to give them step one, a sheet of paper which had 2 lines on it, actually code. So, okay, this is your first bit of PyGameZero. Actually, the easiest PyGameZero file is empty. It will work. So just have a PyGameZero file. But the first couple of lines of code, and then I'd feed them a few lines of code at a time. So they were typing in, like you used to do from magazines. If you did that, you probably still can do it. And I sort of one step at a time to get them going somewhere. And at each step, I would sort of highlight some element of the code. Okay, so we've got this list thing, or here we're doing calculation to get half the width to center the thing on the page and on the screen and so forth. And also at each step, I encourage them, because obviously the danger of having copy coding, sort of if you like cargo coding, is that they just do it, blindly and don't really understand what they're doing. So I encourage them to play with it, to change the size, the width, the height, change the color of things, to make sure they understood what the effect was, and also to change the name. So I saw this as well in these last couple of days. Young people, when they're coding, tend to get the idea that the computer knows what the name, the variable name, means. So if you put width equals 5, then they kind of sometimes think it's got to be called width, because the computer knows that it's the width of something. And slightly unfortunately, part of PyGameZero's magic is that it does. There's 2 or 3 magic variables in PyGameZero. One of them is width, one's height, which will actually interpret. But most of the time, if you call it position or size or something else, obviously it's a name. So trying to get that across to the lads, I said, okay, change the name, call it what you like. And I'm glad to say they managed to do that. Most of them did that. There was a bit difficult debugging because I couldn't work out what names they'd given to which objects from when I was helping them out, but it worked. PyGameZero is Python 3 only, so we're using idle 3, Python 3, and so on, with no particular drawback on that one. Okay, then for the hardware, the CamJam kits, I was handing out the worksheet. There's, I think, 4 or 5 worksheets, one at a time. I skipped the first one, which is getting a Raspberry Pi up and running, because we'd already done that. And then I hadn't prepared as well for the hardware sessions, unfortunately, basically because I was using somebody else's worksheets, and I thought, well, that'll be all right then. One drawback there, and which I hadn't foreseen, was that the CamJam sheets, at the moment anyway, use Python 2 and Nano as an editor, which is a perfectly valid choice if you want, but unfortunately wasn't Python 3 and idle, which they've been using the previous weeks. So that was a bit of an issue at one time. So what worked, what didn't? Okay, in general, the boys were engaged enough. So we're talking about 6 or so young teenage boys, 13, 15-year-olds. They didn't all run with it from beginning to end. It sort of hiccuped a couple of times, but basically it worked. It's a 4-session workshop work, it worked. Because they were years 8 to 11, I didn't have to explain things like coordinates and vectors, which with a younger group I might have had to do that when you're sort of moving a ball around the screen, or the screen starts on the top left or whatever. So that was a bit easier. Step-by-step typing did work. I wasn't sure whether it would be the right thing to do, but it did seem to work. And I give them a sheet, then give them another sheet, and give them another sheet, and they'd simply type through. So at least it did work. There was this one time when, for some reason, one of the Pis didn't have the right library on it, but a copy and paste with a key stick from one machine to another solved the problem immediately. So that was quite a simple solution. Oh, sorry, I got to software. So PyGameZero basically did what it needed to do. It got things up and running quickly. We had a game going, fairly easily. So my idea with each step would produce some kind of output, some kind of outcome on the screen. It's not a question of writing 3 lines and it doing nothing. So each step I had to sort of achieve some change to the screen, which meant one of the steps was a little bit tricky because I had to have about 12 lines of code just to get the next step out there, which is building the blocks. But Another thing is that they managed to, so you managed to get a breakout clone in about a page and a half of code. They managed to spot the obvious errors. It was quite rare that I had to come and point out a straightforward spelling stroke capitalization error. Once they'd got their head around the fact that the spelling capitalization would be right, the way I describe this today to the kids, it's like a computer's like a really fussy teacher. You've just got to get everything just so, or it's not going to pass. So once they got that in their heads, then that was fine. As I say, they did, without going wild, they did sort of experiment with quantities and colors and so on. The big win, as it were, was a breakout sort of have a little bat moving across the screen, a ball bouncing off it and hitting some blocks at the top, and they disappear as the ball hits them. So the moving things are the ball and the bat. The ball moves independently, it's just bouncing around and off the edge of the screen, according to the normal sort of coordinate rules. The bat, you move with the mouse. That's the way we did it. You move the mouse, the bat moves with it, which I think was step 4. Step 4 is the first time there's an interaction between they're moving them, something they're doing and what's happening on the screen. Up to then, it's just been static objects or an independently moving ball. And that was a complete winner. That energized them much more than anything else. They'd worked through the previous steps and it was fine. But suddenly, you basically say ball.centerx equals bat.centerx, and they're doing this, and bat.centerx equals mouse.centerx, and suddenly they're moving the mouse and it's moving. And somebody by mistake put bat.centery equals mouse.centerx, or one of those two, and they discovered that as they moved the mouse this way, the bat moved that way. And then somebody discovered if you swap them both round, you moved the mouse around the screen this way, and the bat moved around the screen that way. And this just kept, they'd been doing that all day if I'd let them. So that one point of interaction, I realized later, could have come, if I'd managed it, 1 step or 2 steps earlier, because that really sort of, they weren't unhappy before that, but that really sort of energized them for the rest of the session. And once they got going with it, they were much more sort of interactive about it. So that was, say, the big win, just getting that interaction in place. Okay, what worked for hardware? Well, basically it worked. They were able to get this, the CamJam kit's a very neat thing. You've got a breakout board, a breadboard, and sort of the resistors you need, and they were able to get things up and running fairly easily. Yes, they got the LEDs the wrong way round, several times. Yes, they just didn't quite line up the resistors, with the right column of pins to get the LEDs working and so on. But again, they were able to spot that fairly easily. The diagrams are very good on the CamJam sheet, so that was very worthwhile. They were very chuffed to get lights blinking. I think as everyone's experience who talked about educating the kids, getting a light blinking is something great. You've got this blinking light, and they were able to do a sort of like disco effect, red, green, blue, or whatever, red, green, yellow, whatever it is. And so one lad in year 8, his mum turned up to pick him up, and he's, oh, look, Mum, we've got this light, red, green, blue, red, green, blue, red, green, blue. They did this by cutting and pasting the code. So rather than going to a loop, which at least at that point I hadn't really demonstrated, and they simply realized that if they just cut and pasted code, time.sleep, turn it off, time.sleep, turn it on, time.sleep, turn it off, and change the red to the green to the yellow, it all worked, which is good. It means they're experimenting with the code, even if it's not, as you look at it as software, everything that's not optimum, but it worked. Okay, so what didn't work in general? Well, I have one word here, Minecraft. If you're ever using Raspberry Pis and you don't want to use Minecraft for the session you're doing, it's a great tool, I'm told, then probably take it off, or at least do something to stop them using it. Because when you start up a Raspberry Pi, at least with the, I think off the standard, the current Raspbian desktop, you get 2 nice looking icons on the top. One's Minecraft, and one is Mathematica. Mathematica is this great red blinking star icon, which looks really exciting, and they press it. None of them is interested in Mathematica. They have no idea what it is. They don't know why they're pressing it, but it's a big red icon, and who can resist that? So the effect is, of course, Mathematica takes ages to start up, and you're just waiting and waiting, and it's doing nothing anyway. But Minecraft, as I say, also a great draw. So no matter how much data look, please don't play Minecraft. If you've been over in the simulation center today, you'll see it's kind of the default activity. Kids sit down in front of Raspberry Pi, Minecraft. Okay, so that is one thing which, at least, was a drawback for me. Idle. There's obviously a lot to say about idle. It works. It does, what it needs to do. It's not great. Everybody knows this. There's various people talking and looking at possible replacements and alternatives and so forth. It does work, but yeah, it's not great, and that was a bit of a drawback. One of the main problems I had actually was that, the second thing was then Nano, which isn't bad either, but again, having to use it in comparison was really a bit of a surprise for the kids, particularly because you can't sort of cut and paste with the mouse, and they really expected that. So that was a bit of an issue. One of the main drawbacks I had, I'd reckon I'd probably get 4 or 5 lads for this session. I got 4 lads for each of the 4 weeks, but never the same 4. So I got like A, B, C, D, A, B, E, F, B, E, F, G, CDFA or something, you know, which meant that every week somebody was starting a session or continuing a session they hadn't done the previous week or something like that, which is a bit of a problem. Fortunately, I was kind of half prepared for it, but it was tricky. Okay, particularly in software, at the top of the, one of the very first things they do is set the ball in the middle of the screen. It is something like ball.x. Oh, no, sorry, you don't. You create a rectangle of the ball whose xy coordinate, so xy width height, xy coordinate is width divided by 2 and height divided by 2. And every single one of them was confused by that, because they saw width divided by 2 and assumed that this bit of number had something to do with the width of the ball. So that took some getting over. That's one of those things you just have to sort of get the connection between the calculation and the name and so forth. And another problem is that, at least at the level I was teaching, syntax noise is basically magic. So square brackets, round brackets, commas, they don't really have an understanding of why they're using this and not that, that and not this, and so forth. I actually didn't have the problem I usually have, which is the distinction between names and strings. That didn't seem to faze them this time, but that can be an issue. But this one will say was the punctuation for the syntax was a problem. Hardware, okay, the pin numbers on the GPIO header. I think everyone's probably had this thought or discussion or comment or whatever. Obviously, if you're using the pinouts on the GPIO in the, is it BCM, the Broadcom sort of pinout, then you're not counting them along the actual header itself, and the boys just didn't get the idea. Fortunately, the sheets that we'll be using have a very clear, you can very clearly see which, I just told them count the pins on the sheet, put the lead in there, and that worked. There wasn't really a problem with it. You can also get nice little sort of header sheets or layout, which we didn't have any, but you can get those to put on top and so on. But it's a consideration that, and because I was working off the an existing worksheet, I didn't have any choice really but to use those. As I mentioned, I tried to, for the final week, I'd hoped to get the hardware and software working together. Didn't really happen, basically because of this issue with having different boys each time. It was, you know, I just didn't have enough forward motion on the whole project to get to that point. So it wasn't terrible, but it was a bit of a shame. And as I say, I was less well prepared for those last 2 weeks, the hardware weeks, because the first 2 weeks had basically been my code or code I'd written or been involved in, because I was actually contributing a little bit to PyGame0 and hoped to get involved in a sprint here. And so I was really quite well up on it. The hardware stuff I simply knew less about. So I was less involved. I was less able to sort of highlight things and pick things out. Okay, so conclusions and takeaways. As a very simple introduction to coding and electronics, it worked. Copying code from a sheet does basically work, but, so this is one thing I forgot to mention earlier, what I tried once or twice but could have done more of and wanted to do more of is using the interactive interpreter to actually try things out. So once, for example, there's a modulo thing when you're trying to work out, I forget what it is, the blocks are on the screen or something, you do, you know, modulo the width of the screen or something. And I was trying to get them to work out what the percent thing would mean by just trying it out of the interpreter. Try, you know, 10 mod 3, try 10 mod 4, and see if you can guess what it's doing each time. And that worked. It engaged them for a little bit, and then, you know, they were able to say, and that's what that's doing in the code. I could have done more of that, and certainly it helped when I did it. The thing I mentioned about having the interaction with the bat earlier on, so you know, the fact that when you move the mouse, the bat moves, it's worth getting that and possibly, you know, a couple of highlights in the code as soon as you can, but also at other intervals. So you've got something, I mean, you're always producing some, so each step produces some output, but having something which just has a little bit of a cool factor about it would have been good to get that in. I allowed for a 2-hour session, but actually 90 minutes is about what my lads could manage, and with a bit of bookending of you know, getting them set up and so on, that worked out quite nicely. It didn't have a break or anything. They were pretty much engaged the whole time, so that fairly much worked out. As I mentioned, if it's not the thing you're doing, I'd sort of get Minecraft out of the way. A bit of a plug here. When I was doing this, I was researching possibilities of the sort of management systems for broadcasting screens or viewing screens. And I actually used briefly X11 VNC, which is workable, does quite nicely. But in fact, I then got involved with the PyNet project, which is a way of sort of classroom managing a bunch of Raspberry Pis. And I've got helping out with the development of that a little bit. If you haven't already looked at it, I encourage you to, if you're in that situation, I encourage you to look at it. It might not suit your need, but it's quite a handy way of bundling together basically things like screen management, screen broadcast, screen locking, messaging and so on. And also it'll handle things like basically you have network logons. So each person logs on to a Pi, it doesn't matter which they log onto a central network, they mount a central file system, and all their work goes into a folder there. And there's even a facility for sort of teacher collecting work from those folders. And you can upload a classroom list, a list of users, which somebody was telling me here on the conference that they'd uploaded their entire school list when they first started doing this, and then a class list through a CSV file. The school database chucks out a CSV file, you upload it into the PyNet, and you've got user accounts for everybody. They log on in the classroom. Anyway, that's a bit of a plug. I didn't actually use it for this session, but I would certainly consider it for future sessions. Okay, well, that's me at the bottom of the screen. I blog at Ramblings Tim Goldenby UK. I'm at Mail at Tim Goldenby UK, and my Twitter handle and most other handles, GitHub and so on, is TJG UK. Thank you very much. Have I got a minute for questions if anyone wants them? Or?
I think we've had questions. You got back on time. So, any questions for Tim?
If not, any? No? Yes? Oh, that's fine then.
Great.
I wish you well. Thank you.
Back on schedule.
Good. Thought it was short.